All right. Hi, everyone. We would like to start. We are, I think, above the timeline at the moment. So I am Hrvoje, but most people call me Lex because my name is very complicated to pronounce. I can tell you later how we came to the nickname. I am the lead product manager of the connected vehicle platform, and today with me we have my colleague, lead architect of the platform, Tomislav. Many of you know that we in BMW are very passionate about performance, about speed and joy of driving, and especially in our M cars, right? Also, we want to bring this passion into our digital offering. We want to also be able to reflect that. Same as we have the joy of driving, we want to have joy of digital services. Therefore, we have created tons of these. We are just highlighting few for you today, such as in-car video streaming, intelligent personal assistant, or optimized charging routes that you know how to get around if your battery is low. It's also about bringing the digital and mechanical together, so automated driving platform is something that really matters today, alongside of the remote upgrades that you can upgrade your vehicle in any part of the globe, but also the location services. We are really proud of the fact that we are operating the world's biggest connected vehicle fleet of more than 24.5 million cars. And this is amounting to almost 12 million upgrades on a daily basis. Our platform is processing around about 18 million requests each day, and this is hosted on more than 1,300 microservices. And I will show you how many clusters we have a little bit later. Our fleet is receiving almost 180 terabytes of data on a daily basis, and we achieve this with remarkable reliability of 99.95%. Why do we state that these figures will grow? Well, the Neue Klasse vehicles are producing and receiving few times more data than the current fleet, and these numbers will multiply heavily as we roll them out more and more as the time goes. Now showing you a little bit more about connected vehicle platform. This platform we internally call Orbit, and Orbit is a service offering for our development teams. So when you want to develop something, we provision a cluster for you, give you all the underlying pieces from network, IAM, observability, anything that you can imagine comes out of the box for you just to care about your application. We are today operating more than 400 EKS clusters in 3 clouds across the globe. Looking at, for example, AWS, we operate in 4 regions worldwide. Platform is used by more than 3,000 developers, and these developers are amounting to more than 130,000 daily builds and deployments. And this number is growing because of the AI. AI is bringing, as you saw from the guys before, more context, more builds, and this number is just exploding. Talking of the 3 clouds that we use, that's AWS, Azure, and Ali Cloud. And if you wonder why, well, some clouds like Ali Cloud are the outcome of regional constraints. Sometimes you don't have freedom of choice for your cloud, and you have to choose a localized provider for certain workloads. On the other hand, you have a bit of strategical competition between Azure and AWS. But we have majority of our workloads on AWS today. Our teams are actually separated. So Orbit, the platform, consists of 8 subproducts. We have 3 core teams, 1 infrastructure team for each cloud, and some shared components like Marketplace that Tomislav will explain later, but also the portal team, the API team, the CI/CD team, and the shared operations layer. How does this look like? So all of the services, all of the microservices actually that are running behind are handled by us, and we are around 80 engineers spread across these 8 teams. And we enable connected vehicle services in every corner of the globe for you. In the between, we have mobile network operator, if you wonder which, any. So just any in different countries, we have different mobile network providers, and they're enabling over the a bit complicated topic, how the hops go from the car to the cloud and back, and also how the interaction goes with our My BMW and Mini app so that you can read your data or you can instruct your vehicle on remote or on the go. What I would like to share with you, this is the fun part, I think, that you came for, not us flexing some numbers. So the platform challenges. We've learned on our journey in the last years that these few highlights, and we will also share at the end few lessons learned, which we see most important, are the ones that really matter. So first one, in the beginning, as we were migrating to the cloud, we decided to put our chips to velocity and development performance. And we have went into the process without clear ownership guidelines. With time, this has backfired onto us because it was unclear during the night who owns what. Where does my responsibility stop and where does yours start? Who is mandated to bring the new feature if we have 2 or 3 teams developing Argo CD parts? So we reverted this decision later on, and today we are operating with very clear guidelines on who owns what. You build it, you own it end to end. It's your responsibility during the day or during the night. The second one is going global. So as we went into AWS, we finished migration, everything was nice. It was like a dreamland, a lot of good stuff, a lot of new services which are not available on premises. We worked above the constraints of missing compute capacity, missing services, and whatever was missing on premises. We ran into a situation where companies said, but guys, we need something in Ali Cloud. This is not enough. And this is how we learned that architecting any solution, you always need to think of portability and flexibility. So you need to know your core risks of your architecture and what are the downsides. Talking of the CI/CD constraints, you know that when you move to the cloud, you're able to harness immense power. So you have fleet of services that you never had before. And talking of the compute, on premises required you to order the new server, and then this order has to pass, the budget has to be allowed, there has to be engineer to install it. It's really stringent process, and it wasn't scaling well. Not to mention the CI/CD build. So on premises, we were maybe handling few hundred builds every day, few hundred deployments, and few hundred build hours. And talking of the cloud and the numbers we saw that others are reaching, we knew it's time to react. So CI/CD was one of the fundamental starting points for us. And of course, compute optimization. I mean, the first thing I will show you also in the runner architecture, which I created with our teams, is that we, with the lift and shift, started unlocking the power of the cloud, but we were badly optimized. So you had one instance type, and it was turned on 24/7. I don't have to go into details. So a lot of bad patterns. This was the initial architecture of the CI/CD. So we had on OpenShift, OpenStack, you had each team had a couple of instances, always the same instance type running 24/7 and executing the Jenkins jobs pipeline. We have some databases, Bitbucket, monitoring, and Prometheus as well for alerting. Of course, as I mentioned, this was not scalable, it was not performant, and it was too costly compared to what we knew that we wanted to achieve going into the cloud. How did we work around that as a platform? Well, the first starting point was lift and shift. Talking of the lift and shift, we wanted to enable our teams as fast as possible and then re-architect and reiterate, you know, these 7 hours of migration. So you can tackle on many different migrational strategies. And we have decided for this case for lift and shift. Why? Well, not every team, when you are talking about hundreds of the teams, it will not be synchronous migration. This is very asynchronous process. So even though it's painful, you need to still serve and operate on premises, but at the same time, you have to unblock your developers in the cloud. And we've done just that. So we created the partially new stack, which is not optimized that well yet in this picture, in the cloud. And already with this architecture, the benefits were higher. So we went from few hundred builds, few hundred build hours to thousands of the builds and 3,000 build hours. This was the next iteration that happened. So we called it Spaceship to represent the true rocket. This is a first of a kind, fully cloud native and managed service that we have created. And this unlocked us to scale well and to unlock the needs that I was mentioning before. So as you can see, there is an SQS, Lambda, and different serverless/managed services being used that was part of the control plane. And control plane had one task to orchestrate the jobs well. Underneath, we had different pools and different auto-scaling groups that were serving the CI/CD jobs. What's different to the lift and shift? Well, first of all, this solution is not anymore one instance. With this, we address the problem of one size fits all. Here we have 33 plus labels that are abstractions for any kind of the job you need. So if you're a development team that is utilizing a lot compute or networking instances or whatsoever, you're free to choose from small to large. And also we tackled the macOS side, so we went into next level of the CI/CD and development in BMW. And it was really passionate and emotional to see the platform grow, because we were sitting monitoring, hitting 20, 30, 40, 50, 100K, 130K plus that we have on average today as a new normal. And this is not where we stopped. So the platform grew from 60 to 130 teams and from 1,000 to 3,000 plus developers. So the word of a good job was spreading really fast and really well. And the second point, just having runners is not enough. So it really matters that you create a good CI/CD pipelining solution. We were operating everything with Jenkins. And Jenkins was one golden pipeline that was bottlenecking everyone. I know golden words are really popular, but golden pipeline backfired in BMW. Every time you were a team and you needed some kind of new feature, you would have to raise feature requests. Feature requests had to be checked by the teams, tons of alignments, too much chat, too little work. And I've decided to change that. So in collaboration with Tomislav and our teams, we have decided to use GitHub Actions, bake the standards inside the lightweight Lego building blocks, so to say, and you use only those that you need, that fits your purpose. If you're a Java team and you are some kind of different team developing different application, you don't need same tests. You don't need same quality gates. You have different rule sets. This solution enables you to do that. So you can build around and just use what you need. So we went from control and audit to flexibility and guardrails. And now the biggest shocker. You might ask, wow, where is all this managed and serverless? Well, that didn't fit BMW Group. Talking of the 3 clouds, talking of all the needs that we need, talking of dog fooding, Tomislav once gave me really harsh feedback. He said, but where is our platform in all of this? And he was absolutely right. So we've created a solution which is microservice-based that you can port to any cloud. We can now orchestrate the brain in Azure, in Ali Cloud, or in AWS, and we stress tested this solution. It can go over 130K. Why was this important? Well, AI world is bringing more trash into the pipelines, more context. It's not all about quality anymore, and you need to ensure to be able to process it fast, process it well, and stop this trash from entering your deployment stages. And you heard that I mentioned the growing pipeline number. So with this approach, we can handle up to 300,000 builds and deployments easy, and we can port to any cloud, as I said. So if you wish to see more detail about it, feel free to check our QR code that we've written together, the blog post with AWS, and you can see the greater detail just around that. And here, I would give a word to my colleague Tomislav to take you into other platform sites.
Thank you, Hrvoje. So when we completed the journey on the CI/CD system, let's go back how the platform actually was shaped. We started our journey from on-prem, migrating to AWS and the cloud provider, and we had the standard building blocks. The Orbit networking, our networking system underneath Kubernetes clusters and add-ons. Add-ons provisioned on top of our platform, all the standard that you know, Grafana, Cert Manager, and on top of this, the application teams. The application teams bringing business logic and adding into the cluster. But the first problems started to raise, and this is the context. The context was too big for the platform team. A platform team had to deal with networking issues, certificate manager issues, connections to on-prem, connections to other regions. It's too much for them. So the cognitive load on a platform team significantly increased. Additionally, the release process and the platform was tied up together. Releasing the networking, you had to release additional version of a Kubernetes model. The add-ons were also tied up together in one single pipeline. So we faced the regular challenges that you could see in a platform teams. Cognitive load, also dependency in between release process, and not able to create small changes between the application and the platform versions. So how did we start to tackle the problem? We separated the teams and the responsibilities. Added that one team is just taking care about Kubernetes and the networking. The other team is taking care about the add-on capabilities and developing add-ons together on Argo CD with it. Additionally, as every platform, we have to enable self-service capabilities. Customers want to configure stuff, add new routes, add new stuff to the platform, configure the environments, add a self-service portal, and develop the API layer around the platform. This allowed us to scale, but unfortunately, this was not enough. Our customer wanted more add-ons. There's one special team, like mentioned Hrvoje before, that wants RabbitMQ operator. Nobody needs it, but they need the RabbitMQ operator. What do? Either you install it to them, and when you install it to them, you give them cluster admin permission, what you don't want to do, or you install it in front of them, and then you have to manage it. You have to manage all the Kubernetes updates. You have to manage the security updates of the operator. Does this scale? On a large scale with so many teams, not. You end up managing all of the add-ons, and your team is getting completely overwhelmed. So we have to find a solution how to not block our customers of our platform, but also not to overwhelm the team with too much operational effort on our side. So we came up with our internal marketplace concept. We developed our Orbit marketplace, where we have a standard set of add-ons that are deployed on all clusters, and we allowed the community to develop their add-ons on top of this, but in a controlled manner, with clear guidelines, how they do it, how they contribute, and what's their operational responsibility. When they add an add-on, first it's managed by them. If we have enough enablement by the community, the platform takes the add-on and additionally does operation for the add-on. This allows us to scale the platform and to open the platform to the users of the platform, what is really important. But as mentioned before, we had additional requirements. BMW has the need to enable more cloud providers. Because of regional constraints, because of competition, as always, the management and also our geopolitics ask us to provide additional cloud providers to enable the platform for Azure and for Ali Cloud. So we decided to split the infrastructure layer into 3 additional teams, taking the same networking blueprint that we created on AWS. Our connectivity patterns that we created from on-prem to the internet, we replicated in the same way in Ali Cloud and AWS, and also in Azure. So therefore, we had the same footprint and the same underlying Kubernetes clusters, but on top of this, we had one team dealing with the add-on structure on all 3 clouds. There again, our marketplace concept really paid into it. And what is basically marketplace? It's underneath Argo CD, Helm chart templates. Helm chart templates where you have configurations and you roll out the add-ons dependent on the cloud providers with a specific configuration for Ali, Azure, and AWS. This is how we are able to scale our solution overall on 3 cloud providers, where one team manages the add-on on top of the platform. This is how we solved the problem of the multi-cloud solution and enabling the add-ons, but we had a core problem in our platform, and this was the engine, the cluster autoscaler. So our engine, our platform, was slow, as if you worked ever with cluster autoscaler, you know adding a new node with a cluster autoscaler with a managed node groups takes up to 5 minutes. We have a lot of teams that have different requirements. Some of them wanted to have specific node or specific, click is not working. So okay, now it's working. You have specific flexibility for additional nodes. So having memory instances, having CPU-based instances, and therefore we had to have additional capabilities to configuring all of these instance types in their clusters. In the cluster autoscaler solution, this was everything backed up with the autoscaling group. Deploying a new node and a node type resulted in a full node rotation of the whole system. So how did our solution look like? We had a stateless managed node group, and we had a stateful managed node group. And in the cluster autoscaler scenario, on the stateful managed node group, you have problems that the cluster autoscaler is not zone aware, so overall, you're having reliability issues. We decided to go the Karpenter way, and we decided to implement Karpenter on our platform. And what was the key difference between the cluster autoscaler and the Karpenter? In Karpenter, you don't have any more autoscaling groups. You have configuration of your cluster, and this is defined in the node pools. And additionally, you define in EC2 node class templates, where you define the AMI underneath the version and the subnets, and also the topology where you deploy your node pools. This is how we added flexibility to our platform, where the platform users were able to configure the instance and the needs what they have by themselves into the configuration of the platform that we enabled to them. So our setup changed with underlying Karpenter setup and different node pools on top of this that can define different instance size and types. Okay, great, we added flexibility, but what was the business outcome? So our setup with the cluster autoscaler, the utilization of the nodes were not enough. So if we look at how we changed it on the Karpenter level from 84 CPU utilizations to 93 CPU utilization on all of our setup. So we were able to add a higher utilization on our nodes, and this is because of the bin packing algorithm on Karpenter. Overall, what does mean bin packing algorithm? So Karpenter is trying to right-size the nodes and is trying to utilize the nodes as much as possible. So instead of having the same boxes everywhere, it's trying to find the right node for the right workload demand. If the cluster or the workload needs 2 GB RAM and 2 CPU, it's getting a right-sized node and not a big with 96 CPU overall. So how did we do the migration from Karpenter, from cluster autoscaler to Karpenter? One of the most important part is pod disruption budgets. When you start your migration and to the Karpenter, you have to make sure that your workloads overall have the right pod disruption budgets. Why? Karpenter is rescheduling the workloads from one node to the other, and if you don't have pod disruption budgets, they will be interrupted. So make sure that you protect your critical workloads and the workloads of your customers with proper pod disruption budgets. Use Kyverno to making sure that every workload has a proper pod disruption budget. Second of all, consolidation policies. Different environments have different needs. In production, we have to be really carefully to don't interrupt too much the cluster, where on int and test, we can go with a more stronger consolidation policy and shifting around pods and workloads. And third, custom node pools. So overall, as said, adding flexibility, so many application teams, we have to make sure that they can configure the node pools like they want. Some of them even want do not disrupt node pools. They don't want that their batch workloads are at all interrupted. So not everything was great, and this is especially a case where we had, where I was on call, and when we introduced Karpenter, and a standard scenario where the application is communicating over the NAT gateway with the internet. Cluster autoscaler setup, 3 nodes, everything the same size. But then comes Karpenter and start to consolidate stuff. And with the consolidation, the workload shift from one availability zone to another availability zone. And we had an outage, actually we had an error port allocation on the NAT gateway because the workload shifted completely to one availability zone. It was easy to solve, for sure, add additional IP to the NAT gateway, but overall, we had to add additional guardrails to our platform to define topology-aware routing, so to spread the workloads over 3 availability zones to make sure that they're evenly distributed. Overall, enough about problems. What was the business outcome of our overall implementation and fixing the engine? is because we have 400 clusters, and saving 10% of the CPU is a quite big amount of money at our side. It's almost 1 million that we just saved on the Karpenter implementation. Here in the QR code, you can go a little bit deeper into it with code samples, how we did the migrations, what was the outcome, and yeah, because of the matter of time, I cannot go through all details, but I want to wrap up the 3 findings, what we had, and the 3 initially very important stuff that we want you to take away from this talk.
So guys, our biggest learnings were that don't be us and start building UI before API. This backfired badly, so developers want more flexibility, and our core business is actually development. Don't ask me why, but we have decided to go with UI before that, and then UI dictates the API layer, and this doesn't really work out, so we reverted also on that path in the past, and now we are building the API first and much more API in front of the UI. UI is something that can definitely wait. The clear ownership and accountability that Tommy mentioned and that I have introduced to you are really important. So people need to know, for the sake of peace also among the teams, but also for the sake of development, who owns what. So we are recommending you to define these really well and to say who is accountable for what and up to which extent. And the third part is the CI/CD is enabler of the future, of course, where you can treat deployments in different ways, but building the code, having the quality gates, having the tests, especially now in AI era that we mentioned, this is fundamental for us, and this is why we are constantly reiterating on our work. And what we like to say, this is just the start. Why? Because it's a journey. None of our solutions is ever done. There is no 100% done solution. As you've seen from the example from the runner side, we are iterating constantly, and in 2 years we will for sure be able to share something new, something different. World around us is changing. And you are invited, of course, to follow us as a driver, as a passenger, or just as a follower of the company. If you're impressed, maybe we have some future BMW drivers. If not, maybe during some other presentation. We would be happy if you are able to share some feedback with us, mostly that we can improve the content, tell us what worked well, what didn't work so well. So that would be highly appreciated. Since we are at the end and we have decided to use whole 30 minutes, we will be around next 2 days and also right after a presentation for any questions. And with that, we would like to sincerely thank you for having us and for attending our talk. Thank you very much.